From the dawn of time, one entity has ruled over the earth. Many believe this entity to be God. Some even believe it to be money. Others believe it to be Burger King's deliciously spicy chicken fries, now for only $2.99. But the truth, what really has ruled over the world, is the group. Group theory was invented by Math M. Maddox in 1764 when he got really drunk with his buddies Algebra, Calculator, and Tom Hanks and decided to make 1 plus 6 equal to 3. What? Today we're going to answer a few basic questions about group theory. What is a group? What are the elements of a group? What was going on through Burger King's mind when they canceled the chicken fries and then brought them back? Make up your mind. So what is a group? A group consists of a set of elements G. Get it? Because it's a group, first letter of group is G. A group must also have an operation you can perform on it. So to shut this down right now, that does mean that One Direction is not a group. You can't add a Harry to a Louis and get a Zayn. When referring to groups in general, we just use an asterisk to represent the operation. The operation you perform must have closure. Closure means that when you perform said operation, you always come out with another element in the group. There also must be an inverse for all values that give a certain value, and we'll call that value E. And if you perform an operation with any value E, you get the same value again. And finally, there's associativity, which means if you move parentheses, nothing's going to happen. In a group, order doesn't matter. Sorry, that's associativity's weird brother, commutativity. Don't tell him, but he's adopted. Commutativity isn't necessarily a property of groups. See, while associativity is about moving the parentheses around, commutativity is about moving the elements themselves around. If there is commutativity, the group is commutative. If there isn't, we get the most original name since calling long strips of chicken nuggets chicken fries. That's right, non-commutative. So now we've covered what generally makes a group, so let's find some examples. Well, there's one group that we all know really well actually, numbers. More specifically, real numbers. For the purposes of this video, I'm just going to deal with integers because this is annoying. So let's run this set of integers through my new invention, the Is This Thing a Groupinator 5000, patent pending, to test if it's a group. Does it contain a set of elements? Well, oh boy, it sure has elements, and a whole bunch of them too. The set of integers would be called an infinite group, because, well, it's infinite. You can count numbers forever, and it will literally never end. Does it have an operation? Yep, the operation for a set of integers is addition. Oh, but Atom, what about subtraction? That's just adding a negative number. Boom, get dunked on, hater. Does it have closure? If you add two integers, do you get an integer? Well, if you didn't, I have no clue why you're in MV right now, and you should probably talk to your counselor about that. The identity value.
Yeah, 0 to something, you get that same thing.
Inverses. What can you add to an integer to get 0? Just the negative version of that number. But most importantly, can you move the parentheses? Yeah. So that defines the group that we've been working with since kindergarten. Well, that's like a lot of numbers, like infinity numbers. And let's just hypothetically say it's 1 a.m. You're working on a math project super late, recording a voiceover for a video. You don't have time to count to infinity. Well, introducing the finite group. There are many different types of finite groups. Rotations and reflections of shapes such as a triangle or a square, like this Kirby. Please don't hurt my family. And modular arithmetic, which is just a really dumb excuse to make those random numbers equal something that... no. Let's quickly touch on both of these. For shapes, we can flip, rotate, and combine these two actions to create a set of values. R's are used to represent rotations, and F's represent flips. It has an operation of multiplication, so R times R is R squared. So that means doing 2 rotations is R squared instead of 2R. Okay, math, thank you. Very cool. It's in a closed group because 3 rotations in a triangle gets you right back to the exact same spot as none. So that makes R cubed our identity function. If you do any flips or rotations, no matter what order you do them in, you end up with the same thing. So this group also has associativity. While it may not inherently seem like it, yes, rotating and flipping shapes is a group. Kind of like how Burger King's chicken fries actually taste really good, even though that ain't chicken. That ain't chicken. So now let's talk modular arithmetic, which is just a big boy word to make 1 plus 10 equal to 4. I swear to God! Mods are a closed system of a certain amount of values that circle around. Take mod 7 for example, which is made up Take mod 7 for example, which is made up of 7 elements. Wait, you think mod 7 goes to 7? No. Wrong.
Stupid!
We start at 0, so the last number is actually 6. A lot of people call these clock problems because it's numbers lined up in a circle, like a clock. Going back to our mod 7 example, the elements in the group are 0 to 6. Your operation is addition once again, but rather than moving down a straight number line like in the set of integers, think of it like moving around a clock. Because there's 7 elements that loop around, 7 is our identity value. Whenever you add 7 to anything, you count 7 from that spot, and you end up right back where you came from. So yeah, 3 plus 7 is now 3. Deal with it. Your inverse is whatever number gets you to 7, which is 0, which is also 7, because 7 plus 0 is 0. Because this group is like a clock, no matter what you add, you always circle around. It has closure, and again, it's just addition, so wherever you put the parentheses, it doesn't matter. To summarize, anything can be a group if it follows these properties. This is just a quick introduction, so it goes much deeper than just counting numbers and moving around shapes. Well, that's all for now, so I hope you learned something. And please, Mr. Southworth, just give me an A on this. I've been up so late. I just want a good grade, please.